Hello everyone, today I want to talk about inverse transforms and what they do. So here's a little example that we're going to look at in a little bit, but first let's define what it means to do an inverse transform. It's quite simple. Let's say you have some space Rn and you have a mapping to another space. Let's also say it's in the same dimension Rn. And let's say we have some element in that space that maps to another element in the other space. And to get from this point to this point, we do some transform of A. Hopefully you've seen this before. All it's saying is you could also think of it as we're transforming a vector into another one with a transform matrix in there, or a standard matrix. Okay, so the question becomes, if we can go forwards, how can we go backwards? It's actually quite simple. You literally just take the inverse of A, if the inverse exists, and you can go back. So it's quite simple, actually. So let's show how this would work. And hopefully the rough idea should maybe make sense. So let's say you start from this point, which we'll call A, and this is point B. Point A to point B can be found with TA. But from point B to point A, that's going to be TA to the negative 1. So let's just add them together. Well, let's just say the B's cancel. From A to A, that's TA negative 1. Okay, and if we remember the identity that a matrix times its inverse is equal to the identity matrix, then, and this should make sense, A to A is if you did nothing, or the identity matrix. Okay, so let's show this. Well, let's assume we have vector 1, 2, 1, and it gets scaled by this TA vector 2, 1, 3, 4. I will leave it to you to prove that if you did the transform, you'd get 5, 10. So it's just a scaled version of this. I guess maybe I should have drawn this a little better. It'd be more like something like that. But just go with it for now. The question is, how do we find TA inverse? Right? Because if we wanna go from 510 back to 2 1, how can we do that? Well, we have to find TA inverse, and to do that, just remember how you find your inverses. Remember, you augment your matrix with the identity matrix and row reduce down, and you'll get this side as A minus 1, and this side you want to reduce down to I. Right? If you haven't done that ever, go ahead and do it. This will be a learning lesson. I'll just show you some steps I did. I did multiply or divided by 1/2 here, and then I did, just to show you my work, 1, 1/2, 0, 5 halves. So I subtracted -3. -3 times the first row to the second row. This remains 1/2, 0. -3 seconds 1. So hopefully you can see I'm just trying to get this into the simplest form I can. And then once you find all that, you're going to get 1, 1, 0, 0. You know, this is many, many, many steps later. I don't feel like drawing it all out. You get 4/5. You get -1/5. You get -3/5. And you get 2/5. So what this says is that TA inverse is equal to 4/5, -1/5, -3/5, 2/5. Okay, so hopefully this process wasn't too hard, but let's actually show that when we take our transformed vector v2 multiplied by ta inverse, we get back v1. Right? That's kind of important that we show that we show that it works. Just beyond this little sub quasi proof that I did here. So let's multiply them. Okay, so if we do this matrix multiplication, let's see what we get. We're going to get, I hope you know how to multiply matrices at this point. You'll see that this will be 2, 1 here. And quite frankly, that's pretty cool that works. And it's not inherently hard once you see it, but just thinking like, oh, why is TA inverse getting us back to where we were? This is why, and hopefully I did a good job showing you why that is. Sorry I'm leaving a lot of the math to you guys, but to be quite honest, I'm very tired. I don't really care to be doing all this crazy matrix math when I don't have to. I already did it, so I'm not doing it again. Sorry, guys. All right, you guys have a wonderful day, okay? Bye-bye.